Mine was woo too. So our next speaker, Ernesto Tagwerker, has a great surname. I am a bit of a, I love German words, especially the really long ones, but Tagwerker is a great surname. And I was like, I know German, it means day worker. Anyway, it's a good name. And according to the internet, there's only 443 people that bear this surname. And we have one on stage today.
Yeah, thank you.
Yeah. So Ernesto is a prolific Ruby blogger. Yes. Well, I've read some of your posts. And he's also the founder of Ombu Labs and FastRuby.io. And he's an open source maintainer. And today he's going to show us how to escape the tar pit. Mm-hmm. So welcome, Ernesto.
All right. All right. Thank you very much. My name is Ernesto Tagwerker, and you can find me on Twitter, GitHub, anywhere with the handle eTagwerker. It's my very first time in Australia and in RubyConf Australia, so thanks a lot for having me. Well, like Mel said, I'm originally from Argentina. I'm actually one of 3 tag workers in Argentina, which is weird. I know all of them. And you might hear some funny words, because Spanish is my native language. But I have been living in Philadelphia for the past 3 years. So then you'll hear probably an American accent, which is also a little weird. Anyway, I love open source. I wouldn't be here speaking in front of you if it wasn't thanks to a lot of other people who published a lot of gems that I use on a daily basis. So I maintain a few gems that you might have heard of. Database Cleaner is a library that helps you keep a clean state between test runs. Bundle Leak is a gem that you can use to find gems that are known to have memory leaks in your application. And Next Rails is a toolkit that helps you upgrade to the next version of Rails. You can do things like dual booting your application and finding incompatibilities with the next version of Rails. So if you're interested in any of those projects, feel free to check out my GitHub page. I'm the founder of a small software development shop called Ombu Labs. We love to work with Rails, Ruby, JavaScript, and we try to contribute as much as possible back to the community. So that's why those projects came to be, some of them. Now, a few years ago, we found ourselves working on a lot of Rails upgrade projects. And we decided to launch a service that it was all about that. And we called it FastRuby.io. Now, every month, we need to assess tech debt in different projects that we've never heard of. So we work a lot with legacy projects, applications that are running Rails in an outdated version and that really need our help to get them to the next version. Now, we need to quickly assess code quality and tech debt in order to decide whether we want to take on the project or not. We don't take all projects. That would be crazy, and we don't want to get stuck in the tar pit because some of these projects have a lot of tech debt. Now, a lot of the insights that I'm going to share with you today are from this service and from our process. The inspiration for this talk is one of my favorite books of all time. It's called The Mythical Man Month by Fred Brooks. In the very first chapter, he talks about the tar pit, this prehistorical scene with beasts that get entangled in the tar pit, and trying to get out, they only get more and more stuck in the tar pit. And there's this great quote that says, large system programming has, over the past decade, been in such a tar pit. And then he goes on to talk about the fiercer the struggle, the more entangling the tar. and no beast is so strong or so skillful, but that they ultimately sink. Now, what I find fascinating about this is that this book was published in the 70s. So he's talking about the past decade being the 60s. And to this day, we still have trouble maintaining and working with legacy projects. Fred Brooks also published an essay called No Silver Bullet, which I highly recommend, where he talks about our struggles as an industry. And I believe that we are either in two states. We're either in the tar pit or we're trying to avoid it. And sometimes when we're in the tar pit, we try so hard to get out of it. And all of our efforts kind of look like this. Yes, of course, The Simpsons have the best example. We try with our best intentions to get out of it, but it only gets us deeper and deeper in the tar. Let's come back to reality. How does it show up in our day-to-day? Well, one example is projects running over budget, saying, yes, we'll ship this project in 3 months, and then 6 months into it, we have no idea when we'll be done with it. Another case is taking forever to ship small changes. Yeah, sure, that thing, I can do it in 2 days. But then 2 weeks go by and you're like, I have no idea when I'm gonna be done with this. And another one is sacrificing quality and increasing tech debt to be paid off later. But we all know that later never comes, right? And then we end up in this situation. And no, it's not fine. Get out of the room. You need to get out of the room, okay? So in our case, is basically we go and we switch jobs and we find another project. Well, I decided to split this talk in 2 parts. The first one is, how do we avoid it in the first place? How can we say, yes, we will take on this project, or no, there's no way I will take this project? And then the second one is, well, maybe we can't say no to the project, so we're stuck with it, and how can we gradually and incrementally pay off technical debt in a controlled way? All right, so let's get started. Next week, your boss might come up to you and say this. Yeah, if you could come in on this great legacy project and maintain it from now on, that would be great. For us as a consultancy, it usually looks like this. Same thing, but it's a client telling us about their project and that their previous developer had to go and do some other thing. Well, before you commit to anything, think about this. This question is going to come up. How long is it going to take to ship this feature? How long is it going to take to patch this bug? And before you say anything, know that the next words out of your boss is probably going to be something like this, because I need it today. So there is always going to be urgency. So how can we quickly assess tech debt or code quality before we take on the project, before we commit to an estimate? Well, good news is that we have 2 options. There are paid services out there, like CodeClimate and CodeScene, and then there are open source gems that you could use. Now, I'm not here to sell you on any of the paid services, but I will talk about open source gems, because even some of the paid services use the open source gems. So these gems will do a bunch of things. The main things are static code analysis. They will read every single statement in your application, and they will tell you how complex the application really is. Then they will also calculate code coverage. They won't really tell you whether your tests are good or bad, but they will tell you how many statements in your application your tests actually run. And another one is code smells. We now know that there are many, many code smells out there, and basically what these tools will do will compare your code base to known code smell patterns, and they will tell you you have 27 code smells in this file. And this will give you an idea of software quality. But what is software quality anyway? Well, the truth is that there are books written about this, hundreds of definitions, quality models, and you have to pick one. And here's a small rant, and it's the only rant I have. But just because there are hundreds of definitions out there doesn't mean you can throw your arms up in the air and say, too complicated, can't do it, that's too subjective, we can't really do anything about it. No, you can't do that. What you can do is define your own baseline for software quality. There are many tools out there in our Ruby community that you can configure to your own will and then use it as the baseline. All right, back to definitions. So the IEEE defines quality like this. And sure, this definition is perfect, it's bulletproof, and it considers everything. And if I want to translate it to human, it says it works as expected. But it's not that simple, right? Like, we don't want to just maintain things that work as expected, because we know that underneath there might be a mess. So my definition of software quality is it works as expected, and it's not a pain to maintain it. So when we look at this ISO 9126-1 software quality model, what I'm talking about in this particular talk is about maintainability. And I believe there are two things that are very important when you're about to maintain a project. First is code coverage. Does the application have any tests? If it does, how many statements in the application are covered by automated tests? And I put this one first because it really does affect the next one, which is code quality. Now, we can judge the quality of code, and we can certainly refactor code, but we're not about to go refactor code that is untested, right? We can, but then we'll have to manually test that everything works, and it's not the most efficient way. So the good news is that in our wonderful Ruby community, we have a lot of tools that help us with these two things. For code coverage, we have SimpleCov. It's this tool that you can install like this, and then you can load it in your test suite like this. This will load it right before your test starts running. And you can run it like this. And SimpleCov will generate an HTML report that looks like this. Now, by itself, it's a data point. It tells you that 82% of your code base is covered by your tests. And that's good. That's really good. But we want to know more about the project before we take it on. In terms of code quality, it's not that simple. There are many options out there. Yeah, Flog, Flay, RubyCritic, Attractor. Some of them are abandoned, and some of them are active. I decided to use RubyCritic for the purpose of this talk. And RubyCritic is interesting because it uses a bunch of the other tools like Flog, reek, SimpleCov, and many others. And I really like this project because it's quite active. There's a lot of development going on here. The two main concepts that it considers are churn and complexity. Now, for churn, it uses this really cool tool you might have heard of. It's called Git. Now, with Git, we can know how many times a file has changed over the period of time. So since the beginning of the project, how many times has default.rb changed? Well, there are 3 commits, so it has changed 3 times. By itself, it's not that interesting. It will certainly tell you how many of your files are the most changed in the project, but it starts to become more interesting when you combine it with complexity. So for complexity, RubyCritic uses Flog. Flog is this really cool tool by Ryan Davis from Seattle RB, and it's been around for more than 10 years. What it does is it runs or it reads every single line in your application, and it tells you a complexity score. Now here it says it's 10.8. What does that mean? Is that a good thing, a bad thing? Well, we can look at how it works. What it does is it parses every single statement in the file, and it assigns a numeric value to the entire file, which is the sum of all the values of all the statements in the file. So, for instance, an assignment operation is 1.2, an eval operation is 6.0, and so on and so forth. It basically measures assignments, branches, and calls. So that's where the 10.8 comes from. And we now know that it's a very low score, which is good. But again, by itself, it's not that interesting. When you combine it with complexity, it starts to become so interesting that you can start gathering insights from it. And the graph looks like this. On the x-axis, you have churn. On the y-axis, you have complexity. So if a file has changed 2 times, but the complexity points are at 100,000, it's going to be on the upper left quadrant. Or if the file has changed 27 times, but the complexity is at 100 points, you'll find it on the lower right quadrant. Running Ruby Critic is super simple. You install it like this, and you can run it like this today on your project. And what it will do is generate an HTML report that looks like this. And you might look at this and be like, yeah, I don't know what to do with this. And it's totally fine. I had no idea what to do with it either. So let's go part by part. On the left side, you have the GPA pie graph, where every single file in your application gets graded from 0 to 100% or F to A. So, OK, we look at this and we're like, well, OK, 25% of our files are either a D or an F. OK, so it's in pretty good shape. Seen worse projects. In order to calculate complexity, it uses Flog and reek. Sorry, it actually calculates the cost of maintaining a file. Now, on the other side, you have the churn versus complexity graph. And this one is super interesting. Sandy Metz and Michael Feathers have written about this very topic, and there are so many insights that you can gather from this. So if we look at it, I think it's helpful to draw an asymptote to basically split the graph in 4 quadrants. Now, the very first quadrant is where you want all your files to live, right? You want your files to change a little bit, but also be very simple. That's the good place. Now, in the upper left quadrant, right, yeah, that's my comment. Yeah, no one understands those files, but they probably work because nobody's changing them. So I really like what Sandy Metz says about these files. It's like, the code never changes, it's not costing us money. So it's OK. I consider this to be tech debt that it's OK to be with. It's not that tech debt is always bad. There's good tech debt and bad tech debt, in my opinion. Now, in the lower right quadrant, you have files that are very simple but change a lot. And they might have good reasons to change a lot. It might be like a translation file or something. Again, this is not your priority because it's not really that complicated. They're very simple to understand. It starts to become interesting when you get to the upper right quadrant. Now, yes, these modules are complex and are constantly changing. And Michael Feathers says something like this. Sometimes a class becomes so complex that refactoring seems too difficult. So you want to refactor it, you want to move it in the right direction, but it's too complicated. And maybe you just don't have the time in this sprint, so you don't do it. Now, looking at all these details, you can answer this question. Should you take the project or not? Well, sometimes it's easier than others. Sometimes you'll see a graph that looks like this, and you'll say, well, 80% of the code is in the upper right quadrant, so I should probably not take on this project. All right, so to recap a little bit. For code coverage, we have SimpleCov, and for code quality, we have RubyCritic. So each tool gives us a signal of the code base. There's one for code coverage, and then we have one for complexity. But the truth is that those two signals are analyzing the same code base. So we could put it in the same graph. And one thought that we had at fastruby.io is, what if we combined them? What if we calculated a new signal based on those pieces of information? And we like to call that signal the StinkScore. I know Tim Riley said this is too negative, but bear with me, okay? It can be a positive thing. The StinkScore is a function of code quality and code coverage. And the main idea behind this is that complex files which lack tests should be our top priority if we're going to be changing them. I think it's easier to see this with an example. So let's say we have food.rb, and we know that complexity and smells is at 10 points each. So we have a total of 100 smell points. Then we have bar.rb with the exact same metrics. If we put them side by side, we see that, okay, they look pretty much the same. So maybe they are equally stinky. Well, no, because you're missing information. You're missing information about code coverage. What if foo had 0% code coverage? And what if bar had 100% code coverage? Perfect coverage. If you look at them side by side again, you'll see that the StinkScore for each of them is different, way different. Foo is certainly stinkier than bar. Thank you. All right, so maybe what you can do with that file is write some tests for food.rb. But we'll go back to this in the part 2 of the talk. The truth is, how can we automate this analysis so you don't have to do this manually? And believe me, we used to do this manually in my company, and it was really tedious. So we came up with this tool called Skunk. Of course, like, who better to ask than a skunk, whether something is stinky or not? Well, this is an open source tool, and it uses a lot of the concepts from RubyCritic to build on top of it. So that's why I was saying, like, a lot of the code that I'm going to show you was written by other people. And you can install it like this and run it like this today. And it will generate a report that's, for now, it's just a command line table, but it looks like this. It's a list of files sorted from the stinkiest to the one that smells the best. And at the end of the table, you'll have something like this. Now, the StinkScore total is not that important because as you add more features to it, it's only going to go up. So you don't care about that one. But you do care about the StinkScore average because it tells you what is the StinkScore total divided by the number of modules. And that's an important metric, and we'll see that in part 2. But in order to calculate it, what I do is I use the RubyCritic's cost method. The cost method combines 2 values, one for code smells and another one for complexity. So for code smells, RubyCritic uses reek. And for complexity, it uses Flog, like we saw earlier. So Skunk uses this cost value, and then it adds a penalty factor. And the penalty factor looks like this. If the file has perfect code coverage, then the StinkScore is basically the cost. But if the file does not have perfect coverage, then there is a penalty factor. So if you have tests that only run 20% of that particular file, the penalty factor is going to be 80. All right, so now we have 3 metrics for the code. One that combines code quality and coverage, what's called the StinkScore. And the good news is that now we know where we are. And that's really important. You really want to know where you are if you want to get out of this place. These are actually the tar pits in Los Angeles. But anyway, knowing where you are is super important because you know in which direction you want to go. And that's where part 2 starts. So how can we gradually pay off technical debt? Well, there are a few ways that we can go about it. First, we can remove files. You know, that's my favorite hobby these days, removing files from a project. And in order to do that, you can use another tool. This one is called CoverBand. Now, it's very similar to SimpleCov in the way that it generates a very similar report, but it uses as the source of truth real production usage. So what you can do is install CoverBand, run it in production for 7 days, and then you'll see a report that looks like this. Now, this will show you that 67% of the code was executed during the week. So you can look at the 23% of the code that wasn't executed and determine whether it is dead code or not. And if it's dead code, great, remove it. You'll be removing complexity from your application. Another way to go about this is, of course, refactoring files. We go back to the graph, and we see that there are 4 different files that could be refactored there. These are great candidates that we could pick. But which one do we pick? Well, I believe that churn versus complexity is not enough to prioritize our next tasks. So that's why I think the StinkScore is really useful, because it gives you a lot of information in one view. You can go back to the table, and you can see all the files, basically all the files and their StinkScore. You'll see that at the very top, you have that file called git.rb. Now, the truth is that 60% is pretty good code coverage. So maybe you can refactor that file and basically get instant feedback whether you're breaking the build or not. So you pick the first one. You go to the graph, you find it there. And OK, then you have to actually read the file and see what it's doing. And maybe you find that the file is doing 2 things at once. Maybe it has 2 responsibilities. So what you can do is split it in 2 different files and do something like this. You can call one git fetcher and git calculator, because maybe those were the 2 responsibilities that it had. And that will create 2 new files closer to the y-axis, and hopefully lower than the complexity that git.rb represented. Then you can use skunk to compare it to master. So you open your branch, you change everything, and then you're ready to submit your pull request. So you can run skunk -b master, and it will tell you what the StinkScore average looks like in the 2 branches. And here you'll see, great, you actually made the code base 10% better. So we can start to have better conversation about technical debt. And the third way is increasing coverage. Now, of course, we want to have less penalty when it comes to the StinkScore. So in order to have less penalty, what we can do is write more tests for files that have 0% code coverage. Again, we go back to the StinkScore table, and we'll see that there are files in that table that have 0% code coverage. Now, there are some files in there that are related to tests, so I'll ignore the first 2. But the third one tells me that reek task.rb has 0% code coverage. And that means that if I add test to it, I'm going to increase code coverage for that file, and the StinkScore average is also going to go down. Okay. So to recap what we saw, maintainability is about code coverage, complexity, and smells. And I believe that this StinkScore is a new way to talk about technical debt. There are too many words that we use to talk about technical debt, like, yeah, I paid off a lot of technical debt. I paid off only a little bit of technical debt. And there are algorithms out there, but none of them are open source. Like CodeClimate has a way to calculate the cost, but it's not open source. This tool is open source. You can go to GitHub and see the formula, and you can certainly collaborate with us on this. And then we can start having better conversation. So instead of saying, I paid off some tech debt with this PR. Yeah, I spent 20 hours and I paid off some tech debt. You can say something like, you know, I spent 20 hours and I paid off 5% of our tech debt with this PR. Or if you're talking to one of your friends who wants to give you a project, or you're talking to a boss, potential boss, that's telling you, yeah, we have a Rails application that it's in pretty good shape. Maybe they could tell you something like this. This project has a StinkScore average of 120. And we can start tracking that metric across all of our projects to have better conversations about tech debt. And the good news is that this is open source. And this is very easy to configure. All the tools that are underneath are easily configurable. So you could basically configure your own baseline for software quality and use the StinkScore based on your own conventions. And the truth is that you could use this tool with bad intentions. And that's not the purpose of this. Like, I don't want you to go and use Skunk to power your next witch hunt. That's like the worst idea ever. Don't do it. What I want you to do is to use this StinkScore to be your compass out of the tar pit. If we track this new metric called the StinkScore average, we can actually see that our changes are either making it worse or making it better. And if you track all the commits in the past 6 months and you see that the StinkScore average has actually been going up consistently, maybe it's about time to have a talk and change something in your culture. All right, so I'd like to say thanks to Ombu Labs and FastRuby.io for sponsoring me to come here. I'm constantly looking for more feedback about this tool, so if you have any comments or even if you just want to use it on your project, that'll be super helpful. You can check it out there on GitHub. And if you have any questions about this after the conference, you can reach out to me on Twitter. Also, if you have any questions, you can come up to me after the talk and we can talk. Or if you just want a sticker, I have brought stickers, and there's this skunk. Happy to give you some skunk stickers. All right, thank you very much.